Hello, algebra students. Mr. Lawrence here, and we're going to follow up, excuse me, yesterday's video, which is all about solution sets, which actually finding some solution sets. We're going to solve some equations. Now, kids only seem to want to find the ones that seem easy to them. And it's such a terrible thing because equation solving can be pretty simple. Man, I'm having a lot of trouble with that shade. Anyway, let's take a look at example number 1 here. I have two equations written in black, and well, one in black and one in blue. And in the black equation, I have the quantity of x minus 1 times the quantity of x plus 3. And I'm telling you that that equals 17 plus x. Now, it may or it may not. Not all equations have solutions. But what I want to point out is the blue equation. It says the quantity of x minus 1 times the quantity of x plus 3. It equals x plus 17. Well, what do you know about these two equations? Well, they're the same equation, aren't they? Didn't I just use the commutative property on the 17 plus x, right? Commutative property of addition. And that allows me to say that these equations are the same. Why would I bother telling you that? Because whatever x equals in this first equation, okay, x will be the same over here in the blue equation. Whatever the one solution is, and in this case, there might actually be two solutions as I look at it. I guess I could do it real quick for you. I'm going to first multiply. Here, let me get a new page to do this. So we're going to have the quantity of x, is it minus 1 and plus 3? Yeah, minus 1 and plus 3, x minus 1 times the quantity of x plus 3. You know, I expect you to have mastered this already. About 17 plus x. So I'm going to do x times x plus 3 minus 1 times x plus 3. And we're going to distribute the x, and we're going to get an x squared plus a 3x, and then minus an x minus a 3. Okay, now I'm going to start simplifying, and I'm going to get x squared plus 2x minus 3 equals, sorry about that, silly mistake there, 17 plus x. Now kids get all freaked out over this. Don't get freaked out. I'm going to take the 17 away. I'm going to take the 17 away. And I'm also, well, let me do that. And then we're going to have x squared plus 2x minus 20 equals x. Now, some of you are probably thinking, well, why did I take the 17 away? Well, this is a quadratic equation, right? You see it's quadratic, it's second degree. We solve quadratics differently than we solve linear equations. You're used to solving 5x minus 2 equals 10, and that's a linear equation, right? Where you're going to get x alone. I'm going to work to get x alone here, but I'm going to use a different method. You're not going to learn this method today, but this is why I'm getting everything to the same side. So now I'm going to subtract x from both sides. I'm going to get 0, and then I'm going to get x squared plus x minus 20. And something we call factoring, which you don't know yet, and you're not being taught it today, will allow me to say that x plus 5, the quantity of x plus 5, times quantity x minus 4 is 0. I'm saying that this trinomial here can be rewritten this way. And since I broke it up into two pieces, and they need to equal 0, one of these pieces must be 0. So I can take x plus 5, set it equal to 0, solve for x, and I'll get x equals negative 5. That's one solution. And I can take x minus 4, set it equal to 0, add 4 to both sides, and I'll get x equals positive 4. So there are two solutions to this equation like I suggested. And the reason I showed you that was because the two solutions for this equation, which end up being x equals negative 5 or 4, or I could write the solution set this way, right? Negative 5, 4. Certainly I could put them, oops, that's supposed to be the bracket there. Sorry. I could put them on a number line, you know, having to show negative 5, having to show positive 4. Don't have to show any other two numbers. And of course, we would just have 2 points right there. and right there. All right. Those solutions are the same for this. They have the same solutions. Now let's drop down to number 2 here. Here we have the original equation, and then we have in blue the quantity of x minus 1 times the quantity of x plus 3 plus 500, which equals 517 plus x. Do you think that's true? Do you think that's true? Well, wouldn't it have to be? All I did was add the same number to both sides of the equation, right? So if an equation is like a seesaw or a balance, right? And I add 500 here, and I add 500 here, doesn't it stay balanced, right? Okay, so incidentally, these solutions here in green would be the solutions for this blue equation in number 1 and also the blue equation in number 2. It might take a little more work to get to them because we're using a larger number, 517 instead of 17, but in the end, it all comes out in the wash. It's the same equation, just written in a different form. Okay, so let's move on down here. And this is really important, the next thing you're going to see. So I hid it. Well, I'm getting rid of that shade. It's just driving me crazy. All right, so what we've seen here in red, and you'll want to get this down, very important. If a number x is a solution to an equation, then it is also a solution to any other form of that same equation. Now, there might be one restriction there. You have to be careful of 0. You have to be careful. Be careful of 0. Okay? Because if 0 should somehow end up in a denominator in the bottom of a fraction, then that would make the terms be non-real numbers and you wouldn't be able to deal with them. You wouldn't be able to solve the equation. That would be the only exception to that. Okay? All right. So here I would get these down in my notes right here. If A equals B, then A plus B equals B plus C. Wouldn't it have to be true because C is the same number? So, you know, if A is 6 and B is 2 times 3, and I add 7 to this side, and I add 7 to that side, aren't I going to get 13 on both sides? It's also true for multiplication. If A equals B, then if I multiply A by the same number that I multiply B by, the new equation will also be equal. Seems somewhat intuitive, but in math, everything has to be explained. We have to understand the little basics before we can just run around and do math, okay? Now over here in green, if A doesn't equal B, then A plus C does not equal B plus C. And I don't believe there are any exceptions to that. Even if B is 0 or C is 0, there won't be anything true there. So would you like to say hello, James?
Hi!
All right. And for the multiplication, if A doesn't equal B, then AC doesn't equal BC. But we do, can you close the door, please? Then we do have to assume that C does not equal 0, because if C were 0, then we could turn that equation true, right? Because 8 times 0. Go ahead and eat breakfast. I'll be up to eat soon. I got to finish the video. Okay, AC does not equal BC, but if C were 0, AC would turn to 0, BC would turn to 0. All right, so it's important to note that not all equations have solutions. No, some have no solution. Okay, no solution. All right, I've got a couple examples here. 3x plus 5 equals 3x minus 7. Well, some of you are pretty smart, and you're going to look at that, and you're going to go, I don't know how that can be. I don't know how I can have the, two different numbers, say A and B, right? A and B, see them? A is 5, B is 7. So A does not equal B, right? Therefore, C plus A does not equal C plus B, right? Just use the commutative property on both sides. Now, some of you won't recognize that. You're going to be a slave to the equation solving. Okay, let's do that. Let's get rid of the x's on one side of the equation. I don't like x's on both sides. Minus 3x, minus 3x. And so I'm going to end up with 3x's cancel. The statement 5 equals negative 7. Does 5 ever equal -7? No, of course it doesn't. They're never equal. There is no solution to this equation because 5 never equals 7. Never. There's no exception. Okay, now look at this one here. X squared equals -25. Well, let's do it intuitively first of all. X squared equals 25 has two solutions, right? It's quadratic. Many quadratics have two solutions, not all of them. Some have no solution, some only have one. But this one we know has two because x could equal a +5 or a -5, right? The solution set would be like this. Okay, oops, that face has an extra growth on it. Let me redraw it. There we go, that's a little bit better. Okay, now, if you're a slave to equation solving, then you're going to take the square root of each side. The problem with that is you're not allowed to take the square root of a negative number, not in the real number system. You have to go in the imaginary number system, which we don't deal with in this class. So this has no solution, okay? You could tell me it's the empty set. You could say no solution, all right? Let's get down to some actual solving now. All right, we're going to start with a real easy one. This better be easy for you. I've got 5 minus 3/5 x equals 20. I'm going to subtract 5 from both sides because my goal is to get x alone. Okay. And that's going to be, what, 15? Now, some of you really get freaked out over fractions. I don't mind fractions because of my friend Wonder Woman. In fact, I am going to multiply both sides by a fraction. In this case, sometimes only a number, but a fraction in this case. I'm going to multiply by a -5/3 and multiply by a -5/3. Why am I going to do that? Well, watch what's going to happen on the left-hand side. First of all, the negatives are going to cancel. Wonder Woman's going to cancel those 5s, and she's also going to cancel those 3s. What's left on the left-hand side? A plain old x. Now all I have to do is come over here and do some canceling. All right, the negative's not going to cancel because there's not another negative. 3 will go into 3 once. It'll go into 15 5 times. There's nothing left to cancel. I do 5 times -5, and I get -25. -25 is the solution to this set, to this equation. There's the solution in words. I could just do -25 as a solution set. I could graph it on a number line. I'm not going to graph it for only one number. All right, number 2, I'm going to do 2 different ways. First of all, most of you will say, hey, let's distribute. So I'm going to go ahead and distribute. And I'm going to get 12x minus 3. Then I have to distribute on the right-hand side. Now, hopefully you're trying these with me. Don't just sit and watch me do them. Pause the video. See if you can figure it out. 9x plus 54. Okay, I don't like x's on both sides of my equations, so I take away a 9x, and then I'll have a 3x minus 3, and that'll equal 54. All right, I've got a two-step equation here. I'm just going to add 3 to both sides, adding 3. I'm going to get 3x equals 57. And I'll divide by 3. And look, I'm going to be smart. I'm going to be smart. Math is too simple to make it difficult. 60 divided by 3 is 20, right? 57 is 3 less. In other words, there's 1 less 3 in 57. The answer is 19. Yeah. 60 divided by 3 means how many 3's are there inside of 60? There's 20. Count them. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. Sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 right there. And then if I go 33, 36, 39, 42, 45, 48, 51, 54, 57, and 60. So you see there, how many 3's are there in 60? There's 20 of them. That's why 60 divided by 3 is 20. Well, if there's 23's in 60, 57 is 3 left. There's only 19. Yeah, there's only 19 of them. Here, try it again. Okay, let's do, I don't know, let me see here. Let's do 78 divided by 2. Well, 80 divided by 2 is going to be 40, right? This is 2 less than 80, isn't it? So there's 1 less 2, 39. Hey, what do you think 76 divided by 2 is? Well, it's 2 less, 38. 74 divided by 2, I went 2 less. There's 1 less 2, 37. Math is too simple. Don't be a slave to the mathematics. Think about what's going on. Try to look at things from different perspectives. Okay, now I promised to do this one a second way, didn't I? I'm going to do it a second way. We got x equals 19. I'm going to leave that answer there. You see if I get the same answer. Okay, remember inverse operations. Division undoes multiplication, right? I'm going to do this problem without distributing twice. I noticed that there's a 3 in front of this quantity. It's 3 times this quantity, and there's a 9 here. Well, I can divide both sides by 3. And Wonder Woman will cause this 3 to cancel with that one, leaving me with just a 4x minus 1. And then I can cancel that 9 with that 3. And on the right-hand side, I end up with 3 times quantity x plus 6, excuse me. Now, I still have to distribute on the right-hand side, but my numbers are smaller and a little bit easier to work with. Plus 18. Don't like having x's on both sides of my equation, so I subtract 3x. And so I get 4x minus 1 equals 18. I thought I had a mistake there. I get x minus 1 equals 18. Now I have to add 1 to both sides. And I get x equals 19. And there I got the same answer. Is one way better than the other? No, absolutely not. I think the second way is quicker. But you can get the right answer the first way. Excuse me. All right, number 3. You've seen me deal with variables on both sides of the equation. Let's do it one more time. I don't like having variables on both sides. Did you notice I tend to almost always subtract the smaller variable, take away the smaller one. It often leaves me with a positive coefficient on my variable. Look, I got a positive 1 here instead of a negative. Negatives are a lot of places where kids make mistakes. They lose a negative, they forget to multiply by a negative, etc. All right, so now I'm going to add 8 to both sides. And we're going to get 5 equals y. And there you go. Now I should really check my answer. I'm going to put 5 in for y. I'm going to get 4 times 5 minus 3. And 5 times 5 minus 8. So 4 times 5 is 20, minus 3 is 17. This is 25 minus 8. Look at that, 17. We got a true statement. They match each other. Therefore, this is the solution. Okay? Of course, again, you can present it like this. That's the set notation. I'm not going to do a number line for an equation with only one solution like that. All right, 3 over 2r equals 1/4. With the variable being in the denominator, you know what might be a smart idea? What I did earlier. I might want to multiply to get rid of my denominator. I'm not actually going to multiply by 2r over 3. I'm not going to use the whole reciprocal this time. I'm going to multiply by a number, whatever number, that will get rid of the 2, the r, and the 4. Okay? And some of you are thinking, hey, what about 8r? Well, 8r is too big. I don't want to use 8r. I know I'm going to have to multiply by an r to get rid of the fraction. So I'll multiply by an r on both sides. What is the smallest number that 2 and 4 both go into? Well, they both go into 8, but it's not the smallest. It's 4. So I am going to multiply both sides of the equation by 4. So what? 4r, that is. Watch what's going to happen. The r's are going to cancel. 2 is going to go into 4 2 times. 2 times 3 is 6. Right over here, the 4s are going to cancel. there's nothing else to cancel. I'll be left with an R. Ooh, that was pretty cool. Let's check it. Let's do 3 over 2 times 6, okay, which is 3 over 12. And then we're going to simplify that fraction and get 1/4. Hey, it's supposed to equal 1/4, isn't it? You know what, I want to do 1 or 2 more of those. I can't promise they'll come out with solutions, but just to model it for you. Let's do 5 over 6R. And let's let that equal 1 over 8. Okay. What am I going to multiply by to get rid of my denominators? Well, I got to multiply by the smallest number that both 6 and 8 go into evenly, the least common multiple. Now, I need the R in here, so put an R. Now, some of you might be thinking, why are you doing an R on the right-hand side? There's no R in the denominator. Because if I do it to the left-hand side, I have to do it to the right. Let's go find the least common multiple at 6 and 8. We know in our 6R and 8, excuse me. And let's count by the larger of the two denominators until we get a number that the smaller denominator goes into. So 8, 16, 24. What's that? 24. Ding, 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 ding. 6 goes into 24, doesn't it? So my least common multiple, the number part, the coefficient is 24. The variable is R. So I'm going to multiply by 24R on both sides. Okay, and here's where Wonder Woman comes in. R is going to go cancel with R. 6 is going to go into 24 4 times. 4 times 5 is 20. Okay, over here, 8 is going to go into 24 3 times, right? Leaving 1s behind. 3R times 1, I'm going to get a 3R. R is not alone, so I'm going to divide by 3. Divide by 3. R is equal to 20/3. Of course, a quick transformation, and I could say that R is equal to 6 2/3. Right? I just turned it into a mixed number. Either answer is okay. 6 2/3 might make more sense to some people, so I'll present it that way. How about one more of those? One more of those. Let's do 4 over 21R, and let that equal, 3 over 14. No, not over 14. Let's do 3 over 7. That'll be better. Okay, so let's go find that least common multiple. The smallest number that all the denominators go into evenly. Well, I know there's going to be an R in it because there's an R as a factor right there. I'm going to count by the largest denominator until I get a number the smaller denominator goes into. Only speaking of the coefficients, the constants at this time. All right, 21. Ding, 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 ding. I've got it. 7 goes into 21 evenly. So that's what I'm going to multiply by. I'm going to multiply by a 21R. I'm going to multiply by a 21R. All right, when I do this, 21R will cancel, leaving 1 behind. So my left-hand side is a 4. 7 will go into 21 3 times. 3 times 3 is 9 times R will be 9R. Dividing by 9 will get me the statement that R equals 4/9. There you go. Okay, now let's go back to where we were. I think I've got one more sample I want to do, and then we're going to wrap this video up. Okay, it's right down here. All right, in this case, I have to do that least common multiple thing, but I'm going to have to multiply all 3 terms by it. So I'm going to rewrite my equation, 2/5 x minus 1. Let me make sure that looks like a 5 there. Not a 6 accidentally. And I'm going to set that equal to 1/4. Okay, let me go find that least common multiple. Okay, I'll tell you what, I'm going to write that as a fraction. Now, I need an x, right? I see x as a factor here, right there. Okay, and I need the smallest number that 5, 1, and 4 all go into evenly. Well, the 1's trivial because 1's going to go into everything, so I'm not even going to consider it. I'm just going to take the largest denominator, 5, and I'm going to count by it until I get a number that all the other denominators go into. Ding, 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 ding. 20 is the answer. 20 is my least common multiple. So I'm going to multiply by 20x. Then I'm going to multiply by 20x. And I'm going to multiply it by 20x. All right, so here, 5 is going to go into 24 times. X is going to cancel with x. 4 times 2 is 8. Okay, here nothing's going to cancel. I'm going to have a negative 20x. I can cancel the 1's, but it never does anything. And then here, 4 is going to go 25 times, and I'm going to get a 5x. All right, I'm going to add 20 to both sides, 20x that is. 20x. I'm going to get 8 equals 25x. Divide by 25, divide by 25. X is going to equal 8 25ths. All right, that's it. We're going to do some equation solving for a couple days here. Make sure we're really good at it. Mr. Lawrence signing off. Have a good night, everybody.